Hello students, how are you doing today? Today we'll be discussing about chapter 18.2, electrical quantities. Now the subtopic is electrical resistance, electricity, and energy. More about electrical resistance. The equation R is equal to V over I is used to calculate the resistance of a component in a circuit. That is, resistance is equivalent to voltage divided by current. For a current voltage characteristics, it is always described by the use of an ohmic conductor, a resistor whose current voltage characteristics, in which current is proportional to voltage, is called an ohmic resistor. Now, let's deal with this question in a 10-volt power supply, which is a current of 5 ampere through a resistor. What is the resistance associated with a resistor? We all know that R is equal to V over I. So to calculate the resistance, V is 10 volts divided by 5 ampere. That gives what? 2 ohms. So the correct option is 2.0 ohms. Let's pick it and see. That is it. Now, the breakdown of the calculation also is available here. Voltage is 10 volts, current is 5 amperes. So R is V over I, that's 10 over 5, that's 2 ohms. Graph of ohmic resistor. The graph shows the typical shapes of the current voltage characteristics for ohmic resistors and for the filament lab. The graph shows both positive and negative voltages. A negative voltage means one flowing in the opposite direction. That means the voltage which is flowing in the opposite direction. The graphs are symmetrical. The current will be the same for a given voltage. The resistance of a wire depends on its length and diameter. Also, the resistance of a wire is proportional to the length and inversely proportional to the cross-sectional area. That will yield or give us what is known as the resistivity of a material. If you want to know the resistivity of a material, you can know it through the what? Resistance. Via this last statement, R is directly proportional to the length and inversely proportional to the what? Area. Now, this proportionality constant will now be written as what? Rho L over A. This rho now is our what? Resistivity. Then we can then define resistivity rho as R multiplied by A over L, and it's usually measured in what? Ohm meter. That is for resistivity. Now, if you are to look at the current voltage characteristics, the one on the far left here with this graph here, uniform graph here, is talking about Ohm's law. The one on the right is talking about that of a filament lamp. Then, where you have current in relation to potential difference, and you have a negative what? Potential difference. Also, for resistor P has a negative potential difference. Resistor Q also has a negative potential difference, while the current also is what? Positive. Electricity and energy. Electricity is a good way of transferring energy from place to place. Mains electricity is alternating current. High voltage is usually the electromotive force of a supply, that means in a circuit. High voltages are used for main supply because it gives a lot of energy to the charge that it pushes around the circuit. Volt is the SI unit of potential difference, which is equal to 1 joule per kilogram. Batteries and power supplies give energy to the charges in a circuit. When cells are connected in series, the electromotive forces, that is their voltages, will do what? Will add up. Now look at this diagram here. The electromotive forces are being added up since the circuit has 3 cells, 1, 2, and 3. The other one on the right also has 3 cells, 1, 2, and 3. But the potential difference is moves around the what? Resistor, while the current passes from what? The positive terminal to the what? The negative terminal of the what? Circuit. The SI unit of potential difference is the volts or joules per coulomb. That is true. So let's check. That is it. Electrical power. Power ratings are indicated in watts or kilowatts. The power rating of an appliance shows the rate at which it transforms energy. Power is the rate at which energy is transferred or transformed. The greater the current flowing, the greater the energy transferred. Now, power is equal to IV, which is current times voltage. We can also have other formulas for power. For instance, now, the generic formula or the simple formula is P is equal to what? IV. Don't forget that from Ohm's law, V is equal to what? I R. That means I can write the formula of power in terms of either current, voltage, or what? The resistance. Let's try and write it in terms of the resistance now. That means I is equal to what? V over R. Then power now becomes, where we have I, we substitute V over R, V over R times V. That gives us V squared over R. We can then also have where we have V is equal to I R, then P becomes I times I R, and that gives us I squared R. So we can add the formula of power in terms of current and resistance, in terms of voltage and resistance, and in terms of current and voltage. Now, this is a transmission line that takes current from the station at high voltage and transmits it to the what? Substation before it is then distributed to the final end user. Now, let's deal with calculating energy. Let's deal with this activity. An electric fan runs from the 230 volt mains. The current flowing through it is 0.40 amperes. At what rate is the electrical energy transformed by the fan? That rate is dealing with power. How much energy is transformed in 1 minute? That means the total energy that is used. Then let's start. V is 230 volts. I is 0.40 ampere. Now, at what rate is electrical energy transformed? That's P, that's I, V, and that is 0.40 times 230. That's 4/10 times 230. This will cancel this. Power now is 23 times 4. That is 92 watts, because power is measured in watts. Then for the energy, H now is equal to power times time, and that is IV times T. I already have 92 watts multiplied by 1 minute. 1 minute is equivalent to 60 seconds. That's 92 times 60, and that gives 5,520 joules. So we have 92 watts and 5,520 joules. Let's click it and check. That is it. So you have the final breakdown of the solution also here. Now, an electric heater is connected to a 10-volt supply. In 20 seconds, 30 columns of electric charge flows through the heater. Calculate the current flowing and the energy transferred by the heater in 20 seconds. We have 10 volts, that's our V. We also have T, to be 20 seconds. Okay, T is 20 seconds. We have Q, either capital Q or small q, to be 30 coulombs. And we have to calculate the current flowing. Don't forget that Q is equals to what? Or Q is equals to IT. So our I now will be what? Q over T. Q is 30 coulombs divided by time is 20 seconds. And that gives coulomb per second is also known as ampere. 30 over 20 will be 1.5 ampere. Now, you have to calculate energy transferred by the heater. Energy transferred by the heater H is IVT. So our I is 1.5 times V, which is 10, times T, which is 20 seconds. Remember 1.5 in our fraction, 3 over 2 times 10 times 20. With this, that gives us 10. 10 times 10, 100, 100 times 3, that is 300 joules. So our answer becomes 1.5 ampere and 300 joules. So let's click it and check. Now, this is also the breakdown of the calculation that I just did. Now, the device X in this circuit is designed to cut off electricity supply automatically if too much current flows. What is device X? Now, if too much current is to flow in and that will damage the circuit, a fuse is made use of. A fuse always have a tiny wire which blows off when there is too much current that is flowing through a what? A circuit. It can be a resistor, it can be an ammeter, it can be a relay. So the correct answer is what? A fuse. Let's confirm. Now, why are the electric lamps in a house lighting circuit normally connected in parallel? If we should look at it this way, connection of resistors probably in parallel or in series. If they are to be connected in parallel, that means the same voltage is going to pass through each of the electric lamps. But if they are to be connected in series, the same current is going to pass through the electric lamp. So don't forget, the same voltage is going to pass through the electric lamp if they are connected in parallel. And it will be the voltage that is coming from the mains, that is coming from the general electric appliance that distributes the voltage in a specific or particular house or habitation. The voltage across each lamp must be the mains voltage. That's correct. Now, before we go, let's deal with the correct statement. Mains electricity is direct current. No. Mains electricity is alternating current. Yes. Now, the third statement, high voltage is not usually the electromotive force of the electric circuit supply. This is wrong. High voltage is the electromotive force of the electric circuit supply. It is the total voltage that goes through an electric circuit. So Main electricity is alternating current. That is the correct statement. Now, with this, we've come to the end of this session. Do well to subscribe to our channel on YouTube and visit our website www.edubbey.com for more of our interactive notes and videos. Bye for now.